The world was waiting in heavy silence as 3 Atlas quietly slipped away from its last observation post, sliding into the dark zone behind the sun that no instrument could touch. The countdown started to perihelion the moment experts promised would clarify whether this was just a familiar phenomenon or something beyond prediction. Then everything sank into stillness. Global asteroid tracking systems suddenly went silent, Space Center display screens flickering between paused and internal review, as if space had thrown up a solid curtain blocking everything behind it. Some claimed it had disintegrated, others speculated about a sudden course change. Whatever the truth out there, it had already etched a new chapter into human history. As 3 Atlas was about to reappear from behind the sun, every observation station on the planet held its breath fragile, waiting for evidence to confirm or deny an entity that might now be permanently beyond control. Because what was about to return was not just a chunk of matter, but could carry a fateful choice. If this mystery still grips you like it does me, stay locked in to catch every development as it unfolds. Share your thoughts on its origin and where you're following from. And to help this community grow stronger, spread the word on your usual platforms or simply among friends. Your attention is what lets us keep exploring stories like this. Part 1. The choice was made. October 29, 2025. Mark that day because it marks the moment we lost the chance to discover. That morning, the object named 3 Atlas, the third recorded visitor from outside the solar system in human history, skimmed behind the sun, at its closest point 1.35 astronomical units from the star's surface. For 48 hours or possibly longer, every telescope on Earth was completely blinded, not equipment failure or technical error, but pure spatial structure. The pure, unavoidable structure of the cosmos had placed the most closely watched object ever tracked right behind a light source we cannot approach, without damaging our sensors. You have to grasp what this means. When an object enters the sun's occultation zone, it steps into territory where clocks stop ground, radar loses contact, and even the most advanced space tools hit their resolution limit. The sun is ridiculously bright, and anything within a few degrees around it vanishes into glare and scatter. So every event with 3 Atlas in those critical hours, every action it took, every form it transformed into, happened in absolute darkness we couldn't reach. The most captivating object in contemporary astronomy disappeared right when we most craved to see it. Then the data stream cut off. NASA's Near-Earth Object Tracking Table, normally updated every 6 hours with new orbital forecasts, and astronomical data, suddenly froze. The International Asteroid Alert System fell silent. Amateur observers hitting their usual forums only found threads pinned with pause notices and security reviews. That's the kind of wording that sparks unease. That's the kind that fuels questions no one wants to face. The core problem lies in the observation gaps. They don't just create ambiguity, they widen the space for interpretations. When evidence disappears, belief floods in to fill it. We shift from the scientific process of observation, hypothesis testing, conclusion, to a more primal form. We become witnesses instead of analysts. We look up at the sky not to gather data but to search for signs. And that shift has changed the entire landscape. Rumors began spreading just hours later. Someone on an online forum claimed to have captured 3 Atlas in an overexposed image not in the expected position behind the sun, but closer offset by 1 degree from the JPL Horizons model. Another thread cited an anonymous observatory reporting a remote sensing data spike. A short but powerful heat pulse flared in the inner solar corona right where the object should have been. Video platforms were flooded with clips, each more dramatic than the last, analyzing radar signals hinting at velocity changes, course shifts and movements no comet should make. Is any of this grounded? We don't know yet. That's the heart of the issue. That's the whole problem, because the chance to verify or rule them out closed the moment. 3 Atlas skimmed behind the sun. Whatever event happened out there is over. The choice, if it existed, if some factor intervened, has been made. We're no longer pursuing a mystery. We're awaiting judgment on an event that concluded while we were excluded. One researcher stated that if this object absorbed energy at perihelion, we would detect signs of intelligence. Not possibility, not denial. We would face evidence of technological will of an entity that chose to modify its path. Another expert who has spent years arguing that interstellar objects could bear artificial traces, saw 3E Atlas as the ultimate challenge, the chance to witness physics and engineering intersect directly. Then the sun blocked it, and now no one knows what we're even testing. But let's clarify what's at stake. If 3E Atlas is just a comet, a chunk of ice and rock on a natural trajectory through the void, the worst case is some slightly off chemistry and a polarization curve that doesn't perfectly match the models. Maybe mildly disappointing, but still acceptable. But if it's something else, if it deliberately split to fool sensors, if it performed a maneuver out of view, if it acted in ways that require more than gravity and sublimation to explain, then we're facing the greatest discovery in human history, and we let it slip away. We stood on the sidelines as the train departed. So what do we do next? We wait. 3. Atlas is moving away from the sun back into observable space. And soon, maybe a week, maybe 10 days, telescopes will capture images. Ground stations will send radar signals. Spectrographs will break the light into wavelength bands. We'll measure brightness, rotation rate, tail shape, and emission lines. We'll build new models and compare them to pre-perihelion forecasts. And we'll understand or think we do. But here's the harsh reality. Even when the data pours in, even with post-perihelion observations to compare, we still lack the critical piece. Because any event behind the sun stays behind the sun. If 3A Atlas changed direction, we see the result, but not the cause. If it was activated by a propulsion system, we see the effect, but not the ignition moment. Direct evidence, if any, has been pushed out of reach. That's why this story doesn't follow the usual path of scientific discovery. Normally, we start with observation, build hypotheses, test, and converge on truth. This time, we're working backward. We're reconstructing the scene after the investigators left. And the more I reflect, the more I see we haven't even asked the right question. We're not asking what 3 Atlas is. We're asking what it has become, because whatever it is now, it transformed during the signal loss. So let's hold tight to what we truly know. Let's cling to verified facts before diving into guesses and rumors. Because if we want to guide this story responsibly, we must distinguish signal from noise. We must determine where data ends and myth begins. And we must act fast before the new observation window opens, forcing us to confront the truth lurking out there in the dark. Part 2. What we grasped before the curtain fell. The object now called 3 Atlas was detected on July 1, 2025 by the final asteroid impact warning system. That was the Atlas survey, that automated telescope network designed to spot potential hazards. At first, it resembled a typical near-Earth asteroid, a small dot sliding across the star background. But just days later, follow-up observations revealed the anomaly. The object was moving extremely fast. 60 km per second relative to the Sun, nearly double the expected speed for any object gravitationally bound to the system. Orbital analysis confirmed the astronomers' suspicion. The orbit was not elliptical, it was hyperbolic with an eccentricity of 6.14. That's the mathematical signature of an interstellar visitor, an object from beyond the Sun's influence just passing through on its way elsewhere. Not a stray comet from the Oort cloud. This was a traveler from a distant star system, perihelion calculated at 1.35 AU near Earth's orbit, with closest approach at the end of October. This gave 4 months of research before it looped around the Sun and returned to deep space. 4 months to extract every bit of data describing composition and behavior to answer the questions that haunted us since the strange ice chunk in 2017. What are these things and where do they come from? The follow-up campaign was urgent. Ground-based telescopes across continents scanned 3 times a night, building detailed light curves and refining the orbit. Spectra from Gemini South and NASA's infrared revealed water ice grains in the coma, the gas dust layer around the nucleus. The spectral slope matched D-type asteroids, carbon-rich and common in the outer system. Up to this point, nothing unfamiliar. Looked like a comet. Moved like a comet. Maybe it was a comet. But the James Webb Space Telescope joined in. Webb's mid-infrared detected an anomaly in the coma. CO2 to water ratio, 8:1, abnormally high compared to the usual 1:1 in comets. This ratio suggests formation in an ultra-cold CO2-rich environment, perhaps the outer edge of a protoplanetary disk or a dark molecular cloud. Not just an interstellar comet, a comet from a strange place with chemistry different from our region. Then came the polarization, a research team measured polarized light scattered from 3I Atlas's dust particles and found an anomaly, submitting a preprint to Archive before peer review. The object showed a negative polarization branch, concave curve at small phase angles, 2.7% at 7 degrees. Sounds technical, but it's significant. No comet has ever produced such extreme polarization. The curve was steeper than any comet, even the 2019 interstellar Borisov. The negative branch relates to ultra-fine dust, perhaps particles with strange composition or porous structure. The inversion angle, where polarization shifts from negative to positive at 17 degrees, was also anomalous. Each new measurement pushed 3I Atlas deeper into the unknown, not just an interstellar visitor, an interstellar oddity. Imaging confirmed tail development as it approached perihelion, exactly as expected from sublimating ice under increasing radiation. Brightness measurements showed steady activity, no sudden gas releases. No fragmentation, no light curve changes, suggesting structural breakup or loss of large pieces. The object was stable, intact, behaving like a normal comet near the Sun. Importantly, no confirmed orbital anomalies. JPL Horizons data and other tracking showed position residuals differences between predicted and observed within expected error. If 3I Atlas deviated from a pure gravitational orbit, the deviation was subtle enough to go undetected. Comets often have non-gravitational acceleration from gas release, small rocket effects causing shifts, but nothing in 3I Atlas suggested propulsion or active motion. Yet, that's the baseline. What we knew before the Sun's occultation. An interstellar comet with strange chemistry, unusual dust on a hyperbolic orbit, heading back to deep space in a few months. Interesting, historic, but not revolutionary. The data suggested natural, just formed in different conditions around another star. If observations had gone smoothly through perihelion and beyond, we'd probably write papers on strange ices and debate dust models, standard science. Except observations didn't go smoothly. October 29th arrived. 3I Atlas slid behind the Sun into the blind spot for telescopes. For 2 days or more, depending on the instrument, nothing at all. No astrometry, no spectra, no radar ranging. No photometric monitoring, just silence. The object tracked continuously for 4 months, disappeared into observational darkness right at the critical moment, passing through the system. This is when science usually hits its limits, because perihelion isn't just close to the Sun, it's a stress test. The object faces strong thermal gradients, UV bombardment, tidal forces, coronal plasma interactions. Comets disintegrate at perihelion. Surfaces crack, buried volatiles explode from under insulating crusts. If 3I Atlas was going to surprise, change direction, break, flare unusually, perihelion was the time. And we didn't observe. That's what haunts me. The moment a celestial body reveals its true nature coincided with our biggest blind spot. Conspiracy theorists call it suspicious. Science calls it frustrating. I call it the worst luck in astronomy, because post-perihelion interpretation will always be viewed through the lens of the gap. We'll always wonder what we missed. So when people claim they saw something strange, forums flooded with accusations of orbit changes, sudden heat, dashboard issues, unnatural behavior. The uncertainty is real. The observation gap is real, and the gap belief takes root. But before diving deep into rumors and speculation, understand what actually emerges from the information void. Because the noise tells us as much about us as about 3I Atlas. Part 3. Noise, Rumors, and Data Gaps. Just 12 hours after perihelion, online forums exploded. Places for sharing astrophotos and scopes now flooded with threads about 3I Atlas doing the unthinkable. User Asteroid Tracker 6115 posted coordinates from a backyard image compared to JPL Horizons. According to the measurement, the object was not in the expected position, not a small offset, a full degree of arc on the edge of the Sun, instead of behind. 1 degree sounds small, but at that distance it's equivalent to millions of kilometers off. Position. Not noise. Either loose calculations, wrong target, or a real orbital anomaly. The thread broke. Hours later, amateur observations joined with their own measurements, some confirming the difference, others matching predictions. No consensus on what was seen. Then the dashboard stories. Social media users and astro chat groups reported NASA's display briefly showing pause or security review next to 3i Atlas. Screenshots spread through timestamps were missing or suspiciously off. Some paused, others normal. No official confirmation, no way to verify if the table was flagged restricted or someone faked the HTML. But the timing was suspicious. If the table went down, it was right when the sun blocked, when public tracking was hardest. Routine maintenance software update randomly or hiding interesting sensitive data NASA, or international systems not commenting only fueled rumors. Video platforms joined enthusiastically. Fringe space science channels released videos analyzing spikes from transients, leaked sources of heat bursts in the inner corona at perihelion. Videos showed sciencey charts with data for casual viewers, but no verifiable sources or independent raw data. Could be real, fabricated, misread solar observations unrelated. Don't know for sure. Claims spread strong that 3i Atlas lost its tail completely at perihelion, appearing afterward without the dust gas signature typical of a comet near the sun. Meaning clear. If the tail was gone, maybe it wasn't a comet. Pre-perihelion behavior, just camouflaged shell burned off, revealing artificial underneath. Claim attached to AVI often happens with strange interstellar objects. Press quoted low on 3i Atlas, focusing on spectral anomalies that could only fit metal alloys instead of ice rock. Articles combined social media interview claims, creating impression of certainty, calling artificial. He didn't say that, but nuance doesn't survive headlines. Somewhere in the chaos, someone invented a scale ranking artificiality of celestial objects. 3a Atlas, 6 in the 10th scale, doesn't exist. Low, never proposed, but the idea spread on Reddit, Twitter like established science. By fact-check time, the meme had stuck to the discussion. Let's be clear what we're facing. No claim from orbit offset dashboard glitch heat. Spike tail loss alloys as peer review or official observatory statement. There's space for rumors, boundary between hypothesis and fabrication. Some based on real observations, misunderstood, lacking experience bias. Some clickbait revenue, some frustration, some maybe accurate reports of anomalies not yet public. The issue is perception. How to evaluate claims when official data isn't accessible. Normally, science replicates, report observation, others verify, consensus forms. But with sun blocking, replication impossible. Claims of seeing 3i Atlas strange on 3010, no one can check. The object invisible to everyone unless you assuming truthful. Verification waits for reappearance, transient phenomenon long over. That's how information vacuum works. Reliable data gone unreliable rushes in. Human brain pattern machine evolved to detect threat, opportunity, and info lack. Not good at tolerating uncertainty. Rather wrong answer than none, because wrong at least actionable. So 3e Atlas vanished. Everyone filled the gap with guesses, extrapolation dreams. Some guesses technically plausible, dangerous. Take orbit offset, small delta Vi at perihelion unseen. Outgassing or assumed propulsion, a few ms create position shift measured weeks later. Sure, math works but needs observations before after precise timing to calculate real offset or not. No continuous through perihelion, just guess. Or remote sensing. Claim surge. Coronal instrument detects short heat anomaly from small comet nucleus against sun background. Theoretically, yes, but coronal observations full of bright noise, transient solar activity. Picking signal demands detailed analysis, not released immediately verified. Hidden claim meaningless without public data. Even dashboard glitch explainable mundane. Software pause. Database update. Coordinated tracking network delay. Public for quality assessment. View service interruption as conspiracy cover-up, paranoid. But paranoia grows strong in information vacuum. This is the reminder. Rumors not random. Focus on specific anxieties. Orbit change implies active control while something made decision. Heat burst suggests tech energy beyond passive heating. Tail loss challenges comet hypothesis, opens door to artificial structure speculation. Not random anomalies made up. Specific anomalies most important if 3e Atlas turns out different from comet. We're at a crossroads where science and imagination collide. and the observation gap becomes catalyst for both. The rumors aren't just noise. They reflect deep fears about what might be coming from cosmic darkness. As 3E Atlas gradually reappears, we'll have to sort these stories separate fact from fantasy. But until then, the waiting continues, a wait not just for data, but for the meaning of what we might discover. The universe never forgives haste, and this time it has forced us to slow down, think harder about the gaps in our knowledge. Those gaps don't just hide the object, they hide how we understand ourselves in the vast cosmos. Imagine the first moment the signal returns when some telescope captures the first light from the comet's tail. That will be when every hypothesis is tested, every rumor weighed. But even then, the shadow of the gap will linger, reminding us that part of the story is forever out of reach. We can measure the new orbit, analyze the new spectrum, but the cause behind any change will remain the sun's secret. And in that secret, we humans will keep telling stories, building narratives to fill what we can't know. That's our nature storytellers under the starry sky, always trying to turn voids into something meaningful. 3 Atlas, whether comet or something else, has awakened that primal part in us, the craving to understand and be understood. When it returns, we'll be ready not just with telescopes, but with imagination honed through these days of waiting. But waiting isn't passive. It's time to review what we knew to strengthen the foundation before the coming data storm. Before perihelion 3 Atlas gave us precious pieces: hyperbolic orbit proving distant origin, abnormal CO2 ratio, suggesting unfamiliar formation environment, negative polarization challenging familiar dust models. Those details, though small, anchor us from drifting into the sea of rumors. They remind us that science doesn't always need drama. Sometimes truth lies in patient measurements. And as we wait, the global community connects through platforms sharing not just worry but hope. From backyard amateur observers to professional centers, all are part of this vast network built to face mysteries like 3E Atlas. That unity is the real strength beyond any rumor or gap. It promises that whatever the truth will face it, analyze it, and learn together. November 1st, 2025, as the sun still shields but space begins to open, we stand on the edge. Ahead is the object's return, perhaps with surprises, perhaps with familiarity. But behind is the lesson from the gap that the universe doesn't always let us witness everything, and sometimes temporary blindness forces us to look deeper into ourselves. 3A Atlas isn't just a visitor, it's a mirror reflecting what we're willing to believe, willing to fear, and willing to explore. In these moments, as the countdown continues, stay calm amid the speculation storm. Remember, the real story will be written by data, not network whispers. And when the data arrives, it will tell its own story, perhaps ordinary, perhaps astonishing, but certainly ours. We, the Sky Watchers, will keep tracking, keep asking, and keep seeking answers in darkness and light. The observation gap isn't the end. It's an invitation to prepare better for what's coming. Scientists are refining models, observers checking gear, and the community building sharper questions. 3I, Atlas. Whatever it decided behind the sun will step into a world ready to receive it with all the curiosity and caution humanity can muster. That's the legacy of this gap, not loss, but growth in facing the unknown. And when the object finally appears, perhaps with unchanged orbit tail, still waving composition, still strange but natural, we'll breathe relief but also remember these days when imagination flew far. Or if there's change, a small deviation, a new spectrum, then that's when science truly begins with all the tools and intellect we have. Either way, 3 Atlas has changed us, reminding us the universe is full of unexpected guests, and we are the ones welcoming them. Now as a new dawn rises, look up at the sky with fresh eyes. Not just for the object, but for the stories we tell about it. That's where true truth lies, at the intersection of observation and reflection. 3E, Atlas is returning, and with it a new chapter in our journey through space and time. Be ready because the universe waits for no one, so maybe the whispers spreading don't come from what someone actually witnessed. They probably stem from deep anxiety or silent desire for what might reveal when the final data comes to light. Because we're not just awaiting mere measurements. We're waiting for an answer. We're waiting to determine whether the 4 months of close tracking were study of a random space event or a sign of distant intelligence. And the longer the wait drags, the more ambiguity swells, feeding ever more complex scenarios to explain that darkness. But baseless speculation is just weaving tales. And if we want to recount this journey truthfully, we need to listen to the most credible voices in this dialogue. The researchers, the knowledge disseminators, the bold individuals on the frontier edge, those who navigate between tight analysis and public statements because their shares shape how we approach all other information. Next part, the line between discovery and myth. Avi Loeb isn't your average face in the crowd, and that's exactly what gives him weight in conversations like this. He holds a tenured professorship at Harvard, used to chair the astronomy department, founded the Black Hole Initiative, and advises a laundry list of research outfits. His publication record stretches decades with rock-solid work on astrophysics, cosmic origins, and massive energy processes. For years, he's been steadfast, sometimes stirring the pot, pushing that we have to seriously entertain the possibility of alien tech. His dive into Oumuamua laid the groundwork. When that cigar-shaped rocketing oddball shot past the sun without any clear outgassing push, Loeb co-authored a paper suggesting light pressure on a thin sail could explain the weirdness. Not claiming artificial, just pointing out the data didn't rule it out. Academic reactions ran the gamut from mild skepticism to outright slams. Some called it baseless speculation. Others respected the intellectual honesty in admitting current models didn't cover all the bases. When 3E Atlas showed up, Loeb was ready. His public comments zeroed in on the polarization data, especially that deep negative branch. In talks and online updates, he noted similar signals could come from ultrafine dust with weird refractive indices, maybe metallic or engineered coatings. It could happen, not must. But that nuance often gets lost in the info stream. When media grabbed it, they spun shock headlines about metal clouds and human-made structures. One piece in a major paper went viral, quoting Loeb saying 3I, Atlas vortex signatures. Reality, his words were far more measured. He stressed that when facing an object showing traits unseen in natural bodies, we have to consider every explanation, including artificial, instead of reflexively dismissing it due to old biases about what can exist. It's a stance on method, not a firm conclusion, but that position makes plenty of deep field astronomers uneasy. Because here's the rub. Traditional astronomy runs on caution. Big claims demand big evidence. When you spot something odd, you exhaust every mundane cause before entertaining exotic hypotheses. You default to natural until data completely rules it out. That approach has proven its worth. It avoids rushed conclusions, minimizes false positives, and preserves credibility in a field where public trust is fragile. But caution comes at a cost. It can delay recognition of genuinely breakthrough finds. It creates blind spots where anomalies get brushed off instead of dug into, and it can punish scientists who are too open to ambiguity, those who admit sometimes we don't know what we're looking at. Loeb's stance is essentially a warning that the conservative approach carries hidden risks, that by auto-rejecting artificial hypotheses we might miss the greatest discovery in history. Michio Kaku operates in a different lane. He's a theoretical physicist with solid credentials, but his main gig for years has been outreach and popularization. He pops up on TV breaking down black holes and multiverses in plain language. His take on 3E Atlas fits that mold. He hasn't dropped a peer-reviewed analysis of the object. Instead, he sketches thought experiments for the public, exploring implications if certain observations pan out. His comments about 3E Atlas absorbing energy at perihelion are hypothetical. If the object showed acceleration or course shifts, that outgassing or gravity can't explain, that hints at power beyond passive sources. An anomalous power raises questions about mechanism. Natural, like weird phase transitions in exotic ices, or artificial. Kaku's wording leans into the artificial angle because it sparks public imagination. That's the hook that grabs attention and fuels discussion. Is that irresponsible? Depends who you ask. Some researchers say floating public speculation without solid data is anti-science, confuses audiences, and erodes trust and expertise. Others argue science communication requires turning complex uncertainties into accessible stories, and that demands some simplification and drama. The line between education and entertainment blurs. Then there's the mainstream pipeline from agencies, NASA press releases, peer-reviewed journal pieces, observatory statements. These voices call for patience. They stress current data limits, the need for more tracking, and risks of snap judgments. When pressed on 3E Atlas, they pivot to the value of interstellar objects for illuminating exoplanet formation. Exotic chemistry teaching us about diverse stellar environments and extended monitoring clarifying ambiguities. It's careful, measured textbook science speak. It also leaves answer-hungry audiences feeling empty, because the public doesn't care if 3i Atlas is educational for comparative planetology. They want to know if it's a spacecraft, and mainstream academia won't touch that question with a 10-meter telescope creating a gap, like the one between Loeb and Kaku. They're willing to voice what suppressed articulate possibilities peer review constrains, and that makes them magnets for both support and backlash. Believers cling to their words as proof mainstream science is hiding or ignoring obvious truth. Skeptics accuse them of diluting rigor for self-promotion. But the most striking thing about this dynamic is both sides are wrestling with the same core knot. We don't know what 3i Atlas is. Available data isn't enough for a firm call, and the data we need is stuck behind an unfillable observation gap. So we're stuck in interpretive limbo where every voice, credible or not, conservative or bold, is basically forecasting. Loeb's forecast keeps the artificial hypothesis open. Mainstream astronomy's defaults to natural until disproven. Kaku's amplifies risks to hook the public. Nobody's entirely wrong. They're just playing different games with their own rules and audiences. And those audiences matter because how we talk about 3i Atlas now will shape societal reaction to whatever comes next. If we dismiss all speculation as baseless, we risk passivity if the object is truly anomalous. If we hype unverified speculation, we risk panic or disillusionment if it turns out mundane. The line between science and myth isn't just academic. It touches practical, political, and psychological realities. So when I see Loeb defending methodological openness, or Kaku painting pictures of intelligent energy, or NASA retreating to neutral language, I don't see heroes or villains. I see humans navigating a real-time cognitive crisis with the tools they have balancing intellectual honesty and professional duty. And they all know the truth, whatever it has already happened where we couldn't reach. That's the real tension, not between fringe and mainstream, but between inquiry and witnessing. Science is supposed to test hypotheses, gather evidence, converge on answers through iteration and consensus. But 3i Atlas broke the playbook. The key experiment happened behind the sun. Now we're waiting for results from a test we couldn't watch. That puts everyone, Loeb, Kaku, NASA, and random internet users in the same tough spot. We're all guessing, waiting for the universe to spill. And that wait is almost over. Next part, the sky's void and the meaning of patience. 3i Atlas is coming back. Not to Earth, not into a fixed solar orbit. Back into view. The solar occultation is reversing. The object is now racing out of the inner system, increasing its angular distance from Earth, returning to trackable space without the sun's blinding glare. In just days, maybe already, by the time you read this, instruments will lock on and we'll know. But not really, because the observation gap isn't just temporary ambiguity, it's permanent ambiguity. No matter how 3i Atlas looks post-perihelion, we'll still wonder what it was like at perihelion. If intact and behaving normally, was it always that way? Or did it change behind the sun and we can't see the evidence now? If fragmented, was the breakup natural from heat or an activation we missed? If orbital excess from passive outgassing or control? Every possibility branches and the data to choose is gone. That's the price of the blind spot. Not just missing observations, but losing the ability to definitively interpret what comes after. Science thrives on continuous data. It struggles with gaps. So let's game out outcomes. Scenario 1, 3i. Atlas emerges like a textbook post-perihelion comet. Gas and dust blazing activity ramped up from ice sublimating under solar heat. Tail strong, maybe brighter than before. Spectra still rich in weird CO2, matching exotic but natural formation. Astrometry confirms predicted orbit with small residuals explained by familiar non-gravitational forces. In this case, all rumors bust. Dashboard glitches were just routine maintenance. Orbital offsets were measurement errors. 3i Atlas is just a weird comet from a weird place. We go back to writing dust model papers. Outcome boring. Honestly, most likely. Comets are common. Interstellar ones rare, but plausible. Chemistry varies by stellar environment. Polarization anomaly odd but possibly from undescribed natural dust. Occam's razor favors the simple explanation that fits the data. Natural origin is simpler than artificial. If 3E Atlas looks like a normal comet post-perihelion, we accept it as a comet despite quirky traits, but it won't satisfy everyone because the gap remains. Maybe 3E Atlas did something at perihelion minor fragmentation big gas, burst heat stress and the evidence evaporated. Believers will have their reasons. Absence of evidence is an evidence of absence when the window closed at the critical moment. Scenario 2. Fragmentation. Object emerges from perihelion clearly broken separate fragments or structural debris like symmetric brightening or breakup streaks. Comets do this sometimes. Solar heat causes thermal gradients cracking the nucleus. Tidal forces at perihelion exceed loose binding strength. If 3E Atlas shattered, it suggests mechanically weak structure consistent with porous ice. Natural explanation, clear physics, no breakthrough. But breakup opens speculation doors. Maybe design. Fragmentation, dispersing pieces into different orbits for unknown purpose. Maybe it carried payloads that shed protective shells at perihelion. Maybe the visible breakup was intentional disassembly, not passive failure. Without watching the breakup, we can't distinguish interpretations just from post-breakup fragments. Scenario 3. Orbital anomaly. Post-perihelion measurements show 3E Atlas off position. Path deviates from pure gravity prediction too much for standard outgassing to explain. This is the red flag case, because unexplained acceleration hints at unexplained force, and weird force is where physics gets interesting or scary. Natural mechanisms exist. Maybe asymmetric outgassing, we missed rocket effect. Maybe passage through dense solar wind plasma momentum transfer. Maybe weird sublimation from CO2 ice creating unmodeled thrust. You can always build a natural story if creative, but also the reverse. Orbital change hints at propulsion deliberate control technology, an object that chose to tweak its path at perihelion out of sight. If so, everything shifts. No more geochemistry study. Engineering study. Interstellar intelligence study with methods we can barely imagine. Scenario 4. Spectral surprise. Maybe 3E Atlas shows new emission lines. Weird chemistry signatures, anomalous heat brightness variations hinting at internal energy beyond passive solar heating. Clearest sign something happened at perihelion. Transformation or activation triggered by solar proximity. Again, natural exists. Exotic material phase change, buried ice pockets, suddenly exposed interaction with coronal plasma. But artificial looms. What if 3I Atlas is a dormant probe? Solar-powered activation. If emission lines are waste heat from operating systems. If the object we tracked for 4 months was always artificial, revealing itself when approaching the star-triggered protocol. Scenarios aren't equal probability. Boring comet far likelier than weird. But the weird alternatives keep you up, refreshed telescope schedules and draft servers waiting for first post-perihelion reports. Because we know whether we admit it or not, one scenario rewrites assumptions about our place in the universe. And that's when tracking strategy matters. Which instruments are pointed? Usual suspects, ground survey scopes that caught 3A Atlas first, basic astrometry photometry data. Then the big guns. Gemini Keck giant scopes in Chile. Maybe Hubble if it earns the time. Optical infrared spectroscopy to characterize outgassing composition. Radio telescopes listening for narrowband emissions hinting at artificial signals. Radar stations pinging to measure surface finesse in orbit. Space assets have advantages. James Webb for detailed mid-infrared spectra building on prior CO2 to see coma changes. Solar orbiting imagers for multi-angle shots, parallax for distance velocity more accurate than ground. Every wavelength instrument observatory is booked toward 3I Atlas when it reappears. But concern, even with full firepower, even with every feasible measurement, we still lack perihelion data. We have before and after with a hole in the middle like a magic trick hiding the key moment. If 3I Atlas did anything in that gap, we infer indirectly. See the result without the cause. Measure deviation without knowing mechanism. Reason post data is clear and transparent, won't settle debates convincingly. Suppose astrometry shows orbital deviation, effects beyond typical outgassing, artificial propulsion or missed natural jet. Suppose spectra show new lines unprepared for. Tech waste heat or solar-driven chemical reaction. Suppose radar shows high surface reflectivity inconsistent with porous. Artificial material or new crystalline deposits. Every observation supports multiple explanations. The data gap prevents decisive selection. Papers will argue natural. Others argue anomaly needs deeper look. Social media will explode with claims counterclaims. 3A Atlas continues hyperbolic out of the system, fading beyond reach, leaving more questions than answers. That's the psychological wait right now. We're not waiting for discovery. We're waiting for verdict in a trial already concluded. The cosmic jury deliberated days before perihelion. Now we sit in the courtroom waiting to hear if the universe's rock or intelligence alone or watched accident or galactic norm. Cruelest part, even when the verdict comes we may not understand it, because the evidence we need most vanished. Hidden behind the sun at the exact moment everything happened. Shifted from investigation to witnessing at conjunction. Witnessing doesn't determine truth, just reports what's seen or not and lives with uncertainty. So we wait. Astronomers check schedules. Amateur enthusiasts scan coordinates near the sun hoping for first sighting. Reporters draft speculative pieces on what might be found. Conspiracy folks compile screenshot evidence folders of rumors. All staring at empty sky waiting for a bright dot to appear and say something we're not sure we want to hear. Because nobody wins. If 3 Atlas is just a comet disappointment, relief, praise science, write up weird dust and move on. But deep down disappointment. Got a mystery, something close but not quite extraordinary. Months thinking we were on the edge of the impossible. Then normal, just different chemistry. But if 3 Atlas is different changed course lit up, needs intelligence to explain smaller disappointment. Facing reality, someone else was here. We're no longer isolated in infinite void. Something else moves between stars, chooses paths, maybe watches us from afar. That thought isn't just science. It changes everything about how we see ourselves, our place in the cosmic web of life. And in that waiting, the global community binds tighter than ever. From labs to online forums, people share not just data but emotion. Personal stories of sleepless nights staring skyward, kids asking parents if aliens are real, scientists admitting private fear of the unknown. That's the power of this moment. It unites us in shared vulnerability. As November 1st passes with the sun still the final barrier, we stand at the threshold. Ahead is the return, maybe with surprises, maybe familiar. But behind is the lesson from the dark. The universe doesn't always let us witness everything. And sometimes temporary blindness forces us to look deeper into ourselves. 3. Atlas isn't just a visitor. It's a mirror reflecting what we're willing to believe, willing to fear, willing to explore. In these moments, as the countdown continues, stay calm amid the speculation storm. Remember, the real story will be written by data, not network whispers. When the data arrives, it will tell its own story, maybe ordinary, maybe astonishing, but certainly ours. We, the Sky Watchers, will keep tracking, keep asking, keep seeking answers in darkness and light. The gap isn't the end. It's an invitation to prepare better for what's coming. Scientists refine models, observers check gear, the community builds sharper questions. 3A. Atlas. Whatever it decided behind the sun will step into a world ready to receive it with all the curiosity and caution humanity can muster. That's the legacy of this gap, not loss, but growth in facing the unknown. When the object finally appears, maybe with unchanged orbit tail, still waving composition, still strange but natural, we'll breathe relief but also remember these days when imagination flew. Or if change a small deviation, a new spectrum, then science truly begins with all the tools and intellect we have. Either way, 3 Atlas has changed us, reminding us the universe is full of unexpected guests and we are the ones welcoming them. Now, as a new dawn rises, look up at the sky with fresh eyes. Not just for the object, but for the stories we tell about it. That's where true truth lies, at the intersection of observation and reflection. 3A. Atlas is returning, and with it a new chapter in our journey through space and time. Be ready because the universe waits for no one. 3 Atlas's return isn't just an astronomical event. It's a challenge to collective imagination. In the waiting days, we've built countless scenarios from sci-fi fever dreams to dry analyses. But when the first data trickles in, maybe from a small scope in Chile, or a radar station in Puerto Rico, the pace will shift. Those first pixels, those faint spectral lines, will become the center of the world. And there in the raw data stream, we'll find not just about the object, but about ourselves. Will we embrace the ordinary with joy, or plunge into the chaos of the strange? The answer lies in how we handle the gap, turning it from burden to opportunity to grow. 3A Atlas, whatever it is done that ignited primal curiosity, reminded us the universe is always bigger than what we know. As it streaks through the solar system, leaving a fading trail, will continue the story. Not an ending, but a beginning for new hunts, bigger telescopes, deeper missions into the void. Because if one thing, comet or probe, came from afar, surely others are on the way. And we'll be ready with all the humility and wonder humanity can carry. The solar system, our sun. Our planet aren't special or isolated entities, but part of a network. A highway or a hunting ground. We've been watched, sampled, studied by entities with tech capable of crossing interstellar distances. And we'll have to figure out what that means for everything we thought we knew about safety, significance, and our future as a species. Both outcomes are uncomfortable. Either we're alone in a universe so vast and ancient it's incomprehensible, or we're overlooked in a universe teeming with intelligences that never bothered to introduce themselves. 3E Atlas sits at that crossroads, forcing us to pick which uncomfortable truth we prefer. But that choice isn't ours to make. The decision was made behind the sunlight in those blind hours when the universe shrugged and kept its secrets. All we can do now is wait for the reveal, knowing that whatever we learn, we'll always wonder what we missed. And that wondering will never stop. That's the real legacy of 3E Atlas. Not the discovery itself, but the persistent uncertainty it carves into our understanding. The reminder that the most critical moments can happen out of sight, out of control, and we're left to live with the aftermath. So stop waiting for answers and start considering what the real consequences might be. Part 6. Dust that shouldn't exist. Light does weird things when it bounces off matter. Most people don't think about this because most light we see is unpolarized, oscillating in random directions perpendicular to its path. But when light scatters off surfaces or particles at certain angles, it becomes polarized, meaning the electromagnetic waves align in preferred directions. You measure that polarization as a function of the angle between the light source, the scattering object, and the observer. That angle is called the phase angle, and you get a polarization curve. For most space objects, that curve is positive and fairly predictable. 3E Atlas doesn't play by those rules. The polarization team studying this found something they'd never seen before in any comet. At small phase angles around 7 degrees, the polarization goes negative. Not just slightly negative, but deeply negative, bottoming out at 2.7%. Then it inverts around 17 degrees and climbs into positive territory. That's called a negative polarization branch. And while the phenomenon is known in some asteroids and lab dust samples, the depth and steepness of Atlas's curve is unprecedented. Why does this matter? Because the polarization curve tells us about the physical properties of the scattering particles. Size, shape, composition, and structure of dust grains leave fingerprints in polarized light. An extreme negative branch like this indicates dust particles smaller than typical comet grains, possibly sub-micron scale, with anomalous refractive indices or highly porous aggregate structures. The 17-degree inversion angle is also odd, sitting between what you'd expect from bare ice grains and from dark absorbing materials like carbon. Researchers put out a preprint on Archive trying to model this with standard dust types. They tested various compositions: water, ice, carbon dioxide, ice, silicates, organics, and different mixing ratios. Nothing fit perfectly. The best match required particle sizes and processes very specific, unlike anything we typically see on comets. Not that it's unexplainable naturally, just that the explanation demands tuning parameters to values we've never encountered before. Now compare this to 2I Borisov, the previous interstellar comet that visited in 2019 and 2020. That object also showed a negative polarization branch, but much shallower, about 1.2%, with a more typical inversion angle. Borisov's extreme was unusual compared to solar system comets, but still within known behavior ranges. 3E Atlas is completely off the charts. Whatever dust is sitting in its outer shell, it's scattering light in ways we've never measured before. This is where things get speculative. Ultra-fine dust with a narrow size distribution and weird optical properties could form naturally through exotic sublimation. and fragmentation processes, but it could also be engineered. If you wanted to create a reflective surface or coating with specific optical traits, say to manage heat shield radiation or camouflage, you could design dust particles with precise sizes and coatings to hit the scattering profile you want. Metal-coated grains, for instance, or dielectric spheres with controlled periodicity would produce polarization signatures way different from plain ice and rock. Am I saying 3i Atlas is spewing artificial dust? No. I'm saying the polarization measurement leaves that door cracked open when it should have slammed shut. Natural explanations are still more likely, but they require invoking dust properties we've never seen in nature and can barely replicate in the lab. And that's troubling because if the simplest natural explanation demands extreme parameter tweaking, while the artificial one just needs moderate engineering and is actually simpler than Occam's razor isn't as straightforward as people think, it says favor the explanation with fewer assumptions, not the one that sounds more familiar. If explaining 3E Atlas's polarization naturally requires assuming dozens of specific conditions, grain formation, size, distribution, composition, gradients, aggregation processes, while explaining it artificially just assumes someone built it that way, then the artificial explanation is actually making fewer assumptions. I'm not endorsing the artificial hypothesis. I'm pointing out our intuition about simplicity can mislead us when dealing with truly anomalous data. And the polarization is truly anomalous. No question. The question is whether that anomaly is extreme natural variation or something entirely different. To settle it, we need more measurements. High-resolution spectroscopy could reveal if the dust grains have metallic composition or weird crystalline structures. Radar observations could test whether the grains are porous aggregates or denser material. Polarization measurements at multiple wavelengths would tighten the particle size distribution, and comparing pre-perihelion polarization to post-perihelion will show whether the dust properties changed after the object heated up near the sun. That last point is critical. If 3E Atlas emerges from perihelion with polarization characteristics different from when it went in, that suggests the dust composition or structure shifted during solar heating. Natural processes could cause this. Ice melting away, exposing a refractory core, or heat processing altering grain aggregation. But significant changes would also fit a surface coating or shell burning off, to reveal different material underneath. The technical challenge of these measurements is massive. Polarization measurements require careful calibration to avoid systematic errors from instrument polarization, atmospheric effects, and light diffraction. For a faint object near the sun, those challenges multiply. The confidence interval on that 2.7% negative value is probably larger than the paper admits. Without seeing the full error analysis, it's hard to say. The research team clearly believes the signal is real enough to rush a preprint to the archive. But science has been fooled before by instrument artifacts that look like breakthroughs. So here's the state of play. 3i Atlas shows the most extreme negative polarization branch ever measured on a comet, indicating dust properties unlike anything in our reference catalog. It could be natural, but only if we twist models hard enough. It could be artificial, requiring fewer random assumptions about dust formation but violating our prior expectations of what exists in the universe. Or it could be an instrumental glitch, a measurement error that will resolve with better data. We'll know more when post-perihelion data appears. If the signal persists, if multiple independent teams confirm the measurement, if the anomaly holds up across different instruments and viewing geometries, then we're looking at something that genuinely doesn't fit our understanding of natural dust. And at that point, the artificial hypothesis is no longer fringe speculation, it's a legitimate contender deserving rigorous investigation. But even then, even if we confirm the dust properties are anomalous beyond any natural explanation we can construct, we still won't have proof of artificiality. We'll just have proof of our own ignorance. Maybe there are dust formation mechanisms in other star systems we've never encountered. Maybe interstellar space produces grain aggregates through processes we haven't discovered. Maybe 3A Atlas formed under conditions so bizarre its properties are genuinely unnatural, just alien in a way we can't recognize. That's the epistemological trap. Lack of a natural explanation doesn't confirm artificial origin. It just confirms we don't understand what we're seeing. And in science, admitting ignorance is supposed to be a virtue, the starting point for deeper study, not the end. But in practice, admitting ignorance to the public invites speculation to fill the void, And speculation about interstellar artifacts generates noise that makes clear thinking harder. So we're stuck between the need to acknowledge real anomalies and the desire to avoid fueling conspiracy theories. This polarization is weird. Genuinely weird, unprecedentedly weird. And saying that out loud makes people start talking about spacecraft and alien megastructures, but not saying it undermines scientific honesty and erodes trust when the truth finally comes out. The dust that shouldn't exist is forcing us to choose between intellectual integrity and narrative control. And maybe that's the real lesson here. Maybe 3E Atlas isn't challenging our physics. Maybe it's challenging our epistemology, our ability to embrace uncertainty without falling into skepticism or hasty belief. Maybe the decision that happened wasn't about what the object is, but about what kind of observers we're capable of becoming. And if the dust is weird, the orbit might be weirder still. Part 7: Ghost Trails and Hidden Maneuvers. Orbit prediction is one of astronomy's oldest triumphs. Give us an object's position and velocity. Factor in gravitational pull from nearby masses, and we can predict with uncanny accuracy where it will be months or years later. It's the foundation that lets us forecast eclipses, plot spacecraft flybys, and confidently say asteroids won't threaten Earth. The math of the cosmos is well understood Newtonian mechanics for most cases, relativistic corrections for extreme conditions, perturbation theory for complex multi-body interactions. This cosmic machine runs flawlessly until it glitches. And comets are the glitch makers. They mess with pure orbital predictions because they're not inert rocks. They breathe. As solar heat cooks them, surface ices sublimate jetting gas and dust from the nucleus. Those jets act like tiny rocket engines, quietly nudging the comet off its purely gravitational path. We call this non-gravitational acceleration. Evidence shows up as residuals, tiny discrepancies between where we predict the comet will be and where we actually observe it. For ordinary comets, these residuals are measurable but minuscule fractions of a meter per second over an orbital cycle. We patch our models empirically, tweaking parameters to fit astrometric data. Basically, we treat outgassing as a systematic perturbation that scales with distance from the Sun. It's a bit of a hack not derived from first principles physics, but it works well enough for practical purposes. And for 3E Atlas, throughout the approach, pre-perihelion observations showed residuals within expected bounds. Everything calm, nothing alarming, nothing anomalous. And then the rumors started leaking. Reddit threads exploded claiming the object's post-perihelion position didn't match JPL predictions, offset too large to blame on simple outgassing. Twitter posts, citing unverified radar tracks, whispered about velocity vectors inconsistent with a gravity-only orbit. YouTube videos dissected amateur astrometry and reached a bombshell conclusion: the object changed course while occulted. Of course, none of these claims were verified by professional observatories or peer-reviewed analysis, but they spread like wildfire, hooking a massive audience. So what would a real orbital anomaly look like? Let's game one out. Suppose 3E Atlas executed a delta V maneuver of just 10 mths right at perihelion, perpendicular to its current velocity vector. That's trivial for human spacecraft. Most ion engines can do better, but for an interstellar object it's a huge kick. Over the weeks post-perihelion, that tiny velocity change accumulates, translating into a position offset that grows linearly with time. By mid-November, 1 month later, the offset could reach millions of kilometers. A massive, easily measurable deviation via astrometry. But here's the catch. You can only detect that offset if you have ultra-precise astrometric measurements both before and after the maneuver, with reliability high enough to rule out every other explanation. And other explanations are a messy tangle of real-world observation, telescope pointing errors, timing uncertainty from exposure, integration inaccuracies in reference star catalogs, atmospheric refraction systematic biases, and CCD detector quirks. Professional observatories have protocols to account for and eliminate all these. Amateurs usually don't. So when an amateur astronomer claims they measured 3I Atlas at coordinates different from JPL's prediction, my first question isn't, did the object move? My first question is, how did you calibrate your astrometry? Did you use precise reference stars? Did you account for differential refraction? Did you timestamp exposures accurately? Did you cross-check your result? Because if the answer is no, then the residual you found is far more likely measurement error than physical reality. Single measurement errors, though, can't explain systematic persistent offsets reported by multiple independent observers. If 10 different people using 10 telescopes and 10 data processing pipelines all report the object north of JPL's prediction by the same amount, it's hard to dismiss as simple calibration issues. Then it might be a systematic error in the ephemeris calculation itself. Those are rare but possible, especially with new objects and limited observation arcs. Or, the observations are accurate, and the object did deviate from the predicted path. So far, professional observatories haven't confirmed any orbital anomalies, at least not publicly. The JPL Horizons page still lists 3E Atlas with pre-perihelion ephemeris data apparently extrapolated forward. This could mean post-perihelion measurements haven't been folded in yet, or they haven't shown a deviation large enough to warrant an update. But silence doesn't prove absence of anomaly. Data review and release take time, but it also implies that if there is a deviation, it's either small or still under debate. This is where radar observations become priceless. By bouncing signals off the object measuring time delay and Doppler shifts, you get absolute precision on distance, and velocity completely independent of optical astrometry. But radar requires massive power and giant antennas, while 3E Atlas is small and far away. Planetary radar facilities like Goldstone or the late lamented Arecibo can easily ping near-Earth asteroids, but an interstellar object at 1.3 AU and receding is right at the detection edge. And even if radar campaigns are run and do detect a deviation, will we know immediately? Probably not. Radar data always gets scrutinized internally before release, especially if results are surprising or controversial. Plus, military radar systems exist that can track space objects, but their data is classified by default. So a scenario where someone detects an orbital anomaly via radar and chooses not to announce it right away isn't conspiracy theory. It's necessary scientific caution when facing extraordinary claims. But let's suppose the rumors are true. Suppose 3I Atlas did deviate from its expected path by a significant amount right at or just after perihelion. What natural mechanism could explain such a strong kick? Outgassing is the obvious candidate, but the key issue is scale. If we're talking residuals of just meters per second, typical cometary activity suffices. But if we're talking tens of ms, you need something intense outbursts, sudden large-scale volatile releases when deeply buried ice pockets are exposed, or fracture under thermal stress. Fragmentation also creates velocity changes. When a comet breaks apart, fragments fly off with relative velocities determined by how structural failure propagates, and how asymmetrically gas jets from fresh surfaces pushing pieces apart. If 3I Atlas shattered into multiple pieces during perihelion, and what we're tracking is just one fragment, its orbit would naturally differ from predictions. This wouldn't indicate technology. It would indicate a pathetic pile of rubble that couldn't handle solar heat. And then of course there's the artificial hypothesis. A deliberate course correction executed with precision inside the perihelion blind spot to avoid observation. This requires thrust generated by something entirely different from passive outgassing. Chemical rockets, ion engines, solar sails, mass ejection systems. Whatever the specific mechanism, it's less important than the implication. Thrust implies intent. Intent implies intelligence. And intelligence implies what we're tracking is no longer a comet. How much energy would that take depends on the object's mass, which we don't know precisely. Based on brightness estimates and assumed albedo, we're talking a nucleus, a few hundred meters across mass, around 1 billion kg. That's small for comets, but still enormous. Accelerating 1 billion kg by 10 ms requires 10 gigajoules of kinetic energy plus whatever efficiency losses. For comparison, that's the energy of about 200 kilowatts of chemical fuel, or a few hours of sunlight on a 1 square kilometer collector. In other words, completely physically feasible. An interstellar probe designed for a long-haul trip could easily carry that energy reserve. The engineering isn't exotic. We could build something like it with current tech. Just time and money. But feasible isn't evidence. Just because something could be artificial doesn't mean it is. And the core problem we keep circling is the observation gap. If 3E Atlas did maneuver, it did so when we couldn't see. We'll only see the result, a changed orbit, never the mechanism. And without seeing the mechanism, we can't distinguish a natural jet outburst from an artificial engine burn. Both produce velocity change. Both work via momentum transfer. The only difference is intent. And you can't measure intent with astrometry. So even if later observations confirm a large orbital deviation, even if residuals are too big for comfortable natural models, we'll still be stuck in an interpretation debate. Natural advocates will push exotic, complex, outgassing models. Artificial advocates will point out the absurdity of that tuning and argue a simple thrust is more reasonable. And the data won't settle it because the smoking gun evidence video of the maneuver spectral detection of propellant exhaust radar images showing surface changes is all locked behind the conjunction curtain we can't see through. That's why this investigation feels more like forensics than science. We're examining evidence after the fact, trying to reconstruct what happened from leftover clues. And forensics is always open to interpretation debates because different stories can fit the same evidence depending on your starting assumptions. Orbital residuals, if they exist if confirmed, will tell us something happened. They'll never tell us what. And knowing something happened without knowing what it was might be worse than knowing nothing. But at least orbital changes are mechanical, measurable. When it comes to solar interaction theories, we're venturing into completely uncharted territory. Part 8. When the sun reaches out and touches you, perihelion isn't just closeness, it's immersion. An object passing 1.35 AU from the sun isn't just getting nearer to the light source. It's entering an environment utterly different from the cold, empty void of interstellar space. The solar wind, a supersonic stream of charged particles flowing outward at hundreds of kilometers, becomes dense enough to abrade surface material. The interplanetary magnetic field strengthens, capable of inducing currents in conductive materials. Radiation intensity jumps orders of magnitude, pumping energy into molecular bonds and triggering chemistry impossible in the outer freeze. And of course, temperature skyrockets. For a comet nucleus mostly made of water ice, perihelion is a violent makeover. Ice sublimates furiously, building a thick coma and tail. But 3E Atlas isn't mostly water ice. It's mostly carbon dioxide. And that chemical difference changes everything. Carbon dioxide ice sublimates at much lower temperatures than water. This means 3E Atlas started releasing gas-bleeding material from far out. By perihelion surface, CO2 layers were likely depleted, exposing deeper material, maybe water-rich layers beneath, or maybe something entirely different. Post-perihelion spectroscopy will reveal whether the coma's chemical composition shifted, whether ratios changed abruptly as different volatile reservoirs activated. But this isn't just simple ice sublimation. Perihelion thrusts the object into a furnace of processes we're only beginning to understand. The sun's corona isn't quiet space. It's a chaotic plasma matrix of twisted magnetic field lines and energy transport mechanisms that have puzzled physicists for decades. The coronal heating problem, why the sun's outer atmosphere is millions of degrees hotter than its surface, is only starting to be solved with advanced instruments. And one of those observations is critical here. In 2025, the Daniel K. Inouye Solar Telescope in Hawaii, using its cryo-NIRS-P instrument, directly observed Alphen waves in the corona for the first time. Alphen waves are oscillations in magnetized plasma long. Predicted in theory, but extremely hard to detect. These twist versions involve spiraling magnetic field lines carrying energy and momentum through the corona and out into interplanetary space. Their discovery helps explain how energy moves from the sun's interior, outward, filling missing pieces of the coronal puzzle. Why does this matter for 3I Atlas? Because if Alphenic twist waves carried significant energy flux through the exact region the object transited, they could have interacted with it. A conductive surface, maybe from ionized gases in the coma, or minerals in the nucleus, could couple with these magnetic waves. It would experience induced currents and localized heating far beyond what pure solar radiation could provide. This is a highly speculative mechanism not established for comets but physically plausible. Let's run a quick back-of-the-envelope calc. Suppose those twisty Alphen waves are packing an energy flux of about 10 kilowatts per square meter at that distance. For a nucleus with a cross-section of 10,000 square meters, roughly a sphere, With a 100-meter radius, the total power intercepted is 100 megawatts. Integrate that over a few hours of perihelion fly-through, and you're looking at hundreds of gigajoules of energy. Not enough to vaporize the thing, but way more than enough to trigger brutal localized outgassing, surface cracking, or sudden thermal shifts. Could that explain an orbital deviation? Hell yes. If the energy deposition is asymmetric, mostly cooking one side of the nucleus, the resulting violent outgassing would shove the object like a rocket engine. Totally natural, zero intent, but still a measurable kick. This isn't textbook cometary physics. It's weird tied to freshly discovered solar phenomena, but still 100% natural. Now let's go one step more speculative. What if 3I Atlas was designed to wake up when solar energy crossed a threshold? What if it had been dead quiet, drifting dark through interstellar space for thousands or millions of years, and the perihelion graze was the ignition key to booted up flip on systems for pre-programmed maneuvers or data collection? Solar-powered activation is exactly how we'd engineer a long-haul interstellar probe if we wanted minimal maintenance. Just let it freeze and go dark between stars, then top off the batteries or capacitors when it hits the target. In that scenario, the object wouldn't even need to carry propellant. It could harvest local energy high-efficiency solar panels or thermal collectors during perihelion, then spend it on thrust or sensors. The energy budget we just crunched, hundreds of gigajoules, would be plenty for mission-critical ops comms, maneuvering instrumentation. Any direct evidence for this? Nope, nothing solid, but the circumstantial details are suspiciously neat. The freak polarization dust could hint at engineered optical surfaces. The orbit rumors, if true, could point to active thrust. The timing of alleged anomalies clustered right around perihelion, when energy peaks, matches exactly what you'd expect from a solar-triggered system. And the deadly observation gap during conjunction means if activation did happen, we miss the smoking gun signs, sudden brightness spikes, or start-up spectral emissions. What do we hunt for now to test this excess infrared heat, hinting at an internal power source? Radio emissions, especially narrowband, suggesting deliberate transmission. Brightness changes with a regular pattern too tidy for random tumbling. And of course, an orbital deviation that no passive force can reconcile. None of these are easy. Thermal excess needs razor-sharp models. Radio searches need giant dishes. Brightness tracking needs long-term campaigns. It's hard, specialized work, but doable. If 3I Atlas is artificial and active, the signatures will be measurable. If it's natural, observations will show that too. The only question is whether we grab the data before the object fades beyond detection. Interstellar visitors don't stick around. They scream past, and once gone, they're gone forever. Missing this window means waiting decades, maybe centuries, for the next shot. That urgency creates crushing pressure. Pressure to observe now. Release fast, make claims. And pressure breeds mistakes, rushed conclusions, confirmation bias. Researchers seeing the signals they want to see. We've lived this exact nightmare with Oumuamua. Its acceleration anomalies sparked years of debate. Some cried artificial origin, others pushed natural hydrogen outgassing. The fight still rages because the data is murky and the object is long gone. 3I Atlas risked the same tragic rerun. We're starving for an answer, and that hunger makes us vulnerable, prone to spotting patterns in noise-building stories that outrun the data. Solar interaction theories like alpha waves offer a middle path. Weird mechanisms fully natural that could explain anomalies without invoking tech. But even that sane middle ground needs rigorous vetting. The sun reached out and touched 3I Atlas at perihelion. That's undeniable physics. But what did the touch mean? Was it just roasting an interstellar rock, flash melting ancient CO2 ice? Or did it trigger something deeper, a system dormant for millennia? Or simply peel back a shell to reveal a truth we were never ready to see? The answers to those questions hinge on observations we couldn't make, and maybe never can because that golden moment is gone forever, hidden behind the sun's blinding glare. But if solar physics can still blow our minds with twisty alpha waves we didn't even know existed, what else is lurking in the trickle of data we're about to collect? What other mechanisms, natural or artificial, could explain an object that fits none of our models? And when the evidence is fragmented, when truth is splintered, who gets to decide what the final truth means? This is where we step into Part N, conspiracy governance, and the raw politics of classified space data. The instant an unknown origin object drifts into the inner solar system, it stops being pure science. It instantly becomes a national security issue. Every radar ping, every thermal pixel, every spectral line is politically radioactive. Space agencies and carefully scripted pressers tell us they're transparent. They say planetary defense data belongs to all humanity, a shared legacy. But history, if you listen close, whispers a very different story. The way information flows in high-end space science is always choked by two invisible forces: security and narrative control. When you hit F5 on NASA or ESA sites and see real-time orbit dashboards, you're only seeing the polished surface of a much bigger, deeper, darker machine. Behind that slick UI is a gauntlet of vetting steps, calibration, algorithms, and layered context. Every raw data point before it reaches public eyes passes through countless filters, human, technical, and scariest of all, sometimes ideological. Most people don't realize, or choose not to, that radar data from iconic facilities like Goldstone or the late Arecibo fed straight into North American military defense systems. They weren't just hunting asteroids. They were hunting everything. Even today, civilian radar frequencies for near-Earth object tracking overlap dangerously, with bands reserved for military surveillance, early warning systems, and ballistic missile test tracking. That overlap gives governments both the right and the duty to clamp down on any data that accidentally bleeds into classified channels. The law, in its dry legalese, doesn't distinguish between a weird asteroid and an adversary's hypersonic weapon test when they momentarily share a spectral or radar signature. In the 1980s, the U.S. military ran joint radar campaigns under the cover of asteroid research. Some of those returned signals, sharp, clean-looking alien on printouts, never saw daylight. Not because they were alien, but because they accidentally revealed the exact limits, the blind spots of America's most sensitive detection hardware. Releasing those weaknesses, even for science, could be a national security death sentence. The same applies to optical tracking networks. Satellites quietly cataloging millions of orbital debris fragments in low Earth orbit simultaneously feed position data to classified surveillance arrays. The civilian sky and the military sky aren't just overlapping. They're the same damn mirror two-way. So when the International Asteroid Warning Network IAWN suddenly goes dark, not minutes but hours right after 3I Atlas ducks behind the sun, a dozen plausible explanations pop up: instantly scheduled maintenance server sync glitch, automated cross-agency audit triggered by anomalous metrics, or a classified review. And classified doesn't always mean sinister cabal. It often means something far more mundane, we're not sure. But perception is power. When a system you trust, one that refreshes every 30 minutes, suddenly freezes for 30 hours, the human panic brain does what it evolved to do. It fills the void with a story. Temporary outage sounds perfectly normal until you sync it with the exact moment the object vanished into the inner corona. Classified review sounds serious and responsible, but those two words ignite imagination, plant fear faster than any headline. The legal roots of these phrases are worth digging into. Under signed planetary defense protocols, any data set that might intersect even tangentially with a national security asset can be yanked instantly for interagency verification. Might intersect is terrifyingly vague. It means a weird radar return, an unidentified ranging pulse, or even light curve anomalies. Anything that could mimic military electronic noise, or an unidentified vehicle. Picture this for a second. A low-level analyst at Goldstone gets a return off 3I Atlas, but the automated system in a split-second cross-check matches it to a pattern in a classified library, and flags it as looking like an adversary's hypersonic test signature. Boom. That file never hits the science database. It's auto-routed through defense networks, encrypted on the spot, classified top secret eyes only, and locked behind multiple clearance walls. By the time any civilian scientist gets access, it's redacted, blurred, or simply gone. Then the psychological kicker: the world is watching live. Millions glued to screens, counting down to what excited physicists call the acid test perihelion. The moment solar light and gravity would confirm the object's mundane natural origin, or reveal something far stranger. And then, silence. Black screens. Awaiting data. A data void that stretches. And in that void, imagination, fear, and paranoia thrive. On anonymous forums and encrypted channels, amateur astronomers unbound by protocols start cross-referencing public feeds from Soho No AA. They hunt for missing frames, timestamp glitches, dead pixels. Some claim No A coronal images show an anomalous heat flare, a sudden unexplained brightening in the inner corona lasting under 2 minutes. Others, more grounded, call it sensor artifact, a stray cosmic ray, and a pattern starts to form. The kind of pattern humans wired to find order in chaos are programmed to see, especially when facing the infinite uncertainty of space. Every glitch, every silence, every delay becomes a symbol, a proof. When official dashboards finally flicker back online, toggling between temporary outage and classified review, they're not just technical labels. They're stories. They're admissions that something happened. The irony, none of this requires deliberate malice to be true. The giant, indifferent bureaucratic machine alone can manufacture mystery. Every agency has its own definition of safe disclosure. A single ambiguous result, a not 100% certain signal, can trigger an internal info lockdown lasting days, even weeks. The data chain from telescope mirror to your terminal passes through dozens of hands. Sometimes those hands hesitate. Sometimes they protect reputations, budgets, careers. One reason, and the most defensible, is risk management. If the object shows unexplained energy behavior, say a sudden 10 ms acceleration, or a spectral spike hinting at artificial elements broadcasting that uncertainty to the world, could spark mass panic or uncontrollable wild speculation. In a 24/7 global media ecosystem addicted to virality, "we don't know" is the most dangerous phrase an authority can utter. It's an admission of powerlessness, a more mundane issue, financial liability. Planetary defense programs, space telescopes, they run on public trust and massive congressional funding. One miscalculation big enough to shift an orbit prediction by 1% can trigger ruinous audits, budget freezes, or humiliating congressional hearings. Sometimes it's far safer to shut down, triple-check every calculation, make sure every digit is bulletproof, before anyone outside notices there was a problem. And then the most human, most profound reason, curiosity mixed with primal caution. When facing something potentially history-shattering or heretical, even the most logical scientists feel the unimaginable weight of consequences. An anomaly too juicy, too different, can paralyze institutions. It stops being science, it becomes philosophy, religion. But beneath all the rational explanations runs a deeper current. A question of ownership. Who really owns a discovery when it touches the great unknown? Does the knowledge belong to the agencies, the nations that paid to capture it? Or to all civilization, the ones who'll be shaped by it? In theory, planetary defense is governed by noble open science principles, transparency, global data sharing, collective vigilance. In practice, the chain of custody for raw measurements, those original zeros and ones, is guarded like nuclear codes. If 3i Atlas carried undeniable proof of non-human engineering or physics beyond our standard model, it would test and possibly shatter every protocol written since the dawn of the space age. The first confirmation of extraterrestrial intelligence wouldn't be a scientific paper. It would be a seismic event instantly shifting every power axis on Earth. Religion, financial markets, governments, all would quake. Every belief system propping up humanity for millennia would crumble in hours. At that point, secrecy isn't oppression. It's justified as stabilization. It's the sedative needed to prevent self-destruction. And coordination is the fatal Achilles heel of any active conspiracy. Humans are tragically bad at keeping secrets. We talk too much, we brag. We're haunted by conscience, we make dumb mistakes. Grand perfect conspiracies like faking the moon landing a play requiring thousands to lie in perfect sync. No leaks for decades are statistically near impossible. But there's another kind of conspiracy. One far more dangerous because it requires no coordination. Passive conspiracy or systemic conspiracy. This isn't people agreeing to lie. It's systems engineered to smother truth without any central directive. Now apply that nightmare scenario to 3i Atlas. An intentional cover-up of alien tech with spies and threats would be hard to pull off and easy to crack, but a systemic one that's not just plausible, it's practically guaranteed. The data can be classified by default, shredded by interagency rivalry and jealousy, and completely misinterpreted by the very geniuses collecting it. The most effective cover-up isn't deception, it's fragmentation. Picture this radar data telling us where goes to one expert team in one building. Optical data telling us shape goes to another team on another continent. Spectral data telling us composition belongs to a third team speaking a completely different academic language. None of them have the full picture. They don't just not talk. Even when they do, they don't understand each other. They're siloed in their own knowledge bunkers. Moreover, each team operates through what's called a knowledge filter. Imagine a spectroscopist working late in the lab. She sees a bizarre spectral line on screen, a signal not matching any known element. Her first thought, forged by 15 years of academia, isn't alien tech. Her first thought is instrument artifact, atmospheric diffraction, or calibration error. Her job is to eliminate noise, not chase it. She'll try to calibrate it out, smooth it, discard it as a bad data point, because that's exactly what a dedicated, rigorous scientist does. And that very professional caution, honed over decades, becomes the perfect filter to discard anything truly extraordinary, anything outside the box. The end result is a tragic collective ignorance. Everyone is doing their job perfectly. The radar analyst measures the deviation accurately. The spectroscopist logs the weird lines and flags them unexplained. The orbit analyst notes the residuals and blames unprecedented outgassing. But no one has the authority or even the cognitive bandwidth to connect all those scattered dots. The truth isn't suppressed by shadowy men in black. It's hopelessly trapped in email attachments, buried in 80-page technical reports no one reads, and lost forever in committee meetings arguing calibration methods. This is the most likely and saddest form of conspiracy. It isn't born of malice. It's born of bureaucratic friction and ingrained cognitive caution. The truth isn't hidden. It's simply lost in the white noise, fragmented into 1,000 pieces by the very complex systems we built to understand the universe. The real barrier stopping us from knowing the truth about 3i Atlas might not be a secret cabal. The real barrier might be the structure of knowledge itself, the hyper-specialization of modern science that slices reality into pieces too small. Maybe all the data we need to confirm the extraordinary is already out there, publicly posted on archive servers, but so fragmented it's invisible. It's just silently waiting for someone or something capable of seeing the forest instead of individual trees, and stitching all the pieces together. From probes to natural-looking artifacts, speculation thrives in the dark. When official observation stops, imagination takes the telescope. With 3i Atlas completely vanished behind the sun, the silence becomes a lab for the boldest ideas. In that vacuum where data should be theories, multiply like light refracted through a prism. Every missing frame, every glitched feed, every classified review label becomes a seed of possibility. The first wave of hypotheses didn't come from madness, but from pattern recognition, from the primal human need to finish the cosmic sentence left hanging. The most viral narrative claims 3i Atlas was never inert. It's a probe solar-activated, dormant for millions of years, just waiting for a star's heat to wake it. At first glance, the idea sounds cinematic, but it's rooted in real physics. We know extreme solar proximity can do wild things to materials. Under intense perihelion radiation, composites or metals can develop charge differentials, effectively turning them into self-discharging circuits. If 3i Atlas carried such architecture accidentally or deliberately, a long-dormant antenna array could spark back to life. A sensor buried deep under rock could reboot, and then the evidence gets re-examined, real anomalies in pre-loss photometry. Spikes in the light curve dismissed by mainstream scientists as sensor error, or noise now reinterpreted. They weren't noise. They were a heartbeat, a mechanical heart slowly remembering its purpose. But the second hypothesis dives deeper into the weird. It claims 3i Atlas was never a single object. Instead, it's a distributed architecture. A swarm, not a ship. A cloud of engineered microparticles forming an adaptive dynamic system. In this model, there's no craft to find. The intelligence lies in the pattern how the fragments move and scatter light. Their message wouldn't come via radio waves, but pure geometry. The way light polarizes across the cloud harmonic ratios, in its spectral lines, the eerie blend of dust tails. Sounds poetic, but it fits scarily well before vanishing astronomers at multiple observatories did record faint polarization anomalies. Subtle deviations that weren't random. They showed periodicity, a pattern. Hard to prove, harder to dismiss. The third hypothesis ditches mechanical language entirely. It imagines a message encoded in physics itself, a form of communication so fundamental it's beyond our translation capabilities. Instead of symbols or signals, the medium is the universe's constants. Think of it as algorithmic art etched in motion, a deliberate synchronization between thermal radiation and reflected light, designed to convey information through rhythm timing. A binary pulse train painted on sunlight itself. Avi Loeb once half-joked that if aliens wanted to talk, they'd use physics because physics is universal. Maybe someone out there took it literally, and that unexplained remote energy spike logged right before blackout for believers, that's not noise. That's the first syllable. The fourth and most grounded hypothesis sits on the razor's edge between pure fantasy and achievable engineering. 3i Atlas is a camouflaged artifact. Picture a hollow shell meticulously crafted from rock and ice designed to mimic a comet concealing sophisticated tech inside. The goal isn't speed, it's survival. A cosmic time capsule passively drifting through star systems for millions of years, until a star's signature radiation triggers its wake-up sequence. If true, the masquerade would only reveal itself through behavior, an acceleration no outgassing model can match, a spectrum mismatched to visible surface composition, or a phase-locked thermal lag, where the object heats and cools unnaturally, hinting at internal regulation. So far, observations are inconclusive, but as every astronomer knows, inconclusive is just another word for invitation. Because the faintest signals are enough to sustain belief. To test any of these theories, we return to science's core principle, falsifiability. What can we measure? What can we check? Could deep space radio arrays listening to the cosmos catch a faint narrowband transmission near its reemergence? Could detailed radar mapping reveal micro-velocity patterns, a tiny wiggle too structured for natural? Could high-resolution polarimetry confirm perfect symmetry in the dust tail, incompatible with random ejection? These tests are entirely doable. Some perhaps are already underway, buried under layers of security agreements and national security reviews we've discussed. Yet here's the cruel paradox: the harder we chase certainty, the further it recedes. Because certainty in a case like this isn't an outcome, it's a horizon. Even if 3i Atlas is ultimately proven a mindless chunk of rock, the myth of it will outlive the matter. After all, myth is humanity's instinctive response to data loss. When evidence collapses, belief rushes in to fill the void, and belief, right or wrong, has immense power. It builds telescopes. It funds space missions. It ignites the greatest curiosity. And sometimes it blinds us. If this object was built, the question burns brighter than any solar flare. Who made it, and why not cartoonish aliens but minds operating on scales beyond our biological comprehension? Beings that think in eons, not years. Maybe the builders are long extinct, their creations adrift, technological fossils trapped in the gravity well of a younger civilization. Or maybe it wasn't built by minds like ours. Maybe nature, the original grand engineer, is revealing a new order of physics we lack the math to describe. Once again, we stand on the fragile boundary between science and history. The deep shadow behind the sun where 3i Atlas hides or is hidden either holds the greatest silence in human history, or preserves the first whisper of something that has been waiting for us to listen for a very long time. But before we let these extraordinary speculations fully eclipse the sky, we must consider another possibility. One that requires no alien intelligence, no message, no hidden intent. Because in recent months a quiet revolution in solar physics has unfolded. A discovery that could and likely will explain some of Atlas's strangest behavior without invoking intelligent design. A natural phenomenon, but as profound and bizarre as any artifact. For decades, solar physicists wrestled with a paradox almost poetic in its brutality. The corona, the sun's tenuous outer atmosphere, burns at millions of degrees Celsius, while the visible surface just below it, the photosphere, glows at a mere few thousand. It's as if the air around a flame were hundreds of times hotter than the flame itself. For over half a century, this was one of astrophysics' great unsolved puzzles. Theories rose and fell: magnetic reconnection, nanoflares, plasma turbulence, each explaining a sliver but none accounting for the colossal energy input. The mainstream scientific picture believes 3i Atlas is enduring a brutal survival test. Gravity has pushed it to 68 km/s. Solar radiation heat 736 W mTNKD drives violent sublimation of carbon dioxide CO2 ice that activates at very low temperatures. 78 degrees. This process creates extreme but there's a controversial minority hypothesis championed by Harvard astronomer Avi Loeb. If the comet's orbit changes significantly more than natural chaos predicts, it would suggest something else controlled behavior. In Loeb's hypothesis, 3I Atlas isn't just passively passing the sun, it's performing a gravity assist. This is a standard spaceflight technique using a celestial body's gravity to gain speed and bend trajectory without fuel. The end result is a tragic. An advanced civilization could design a probe to use our sun as a navigation waypoint to chart a galactic course. If we accept that hypothesis, the outgassing we're observing might not be chaotic sublimation. It could be directed thrust fuel jets timed to precisely refine the orbit during the solar pass. That strange nickel vapor layer could be exhaust from an alien propulsion system. The earlier sunward jets could be course correction maneuvers, not sublimation effects. Then Loeb adds another wildly compelling and controversial layer by linking 3I Atlas to the famous 1977 WOW signal. To understand why this is so tantalizing, we must rewind to the night of August 15, 1977. At Ohio's Big Ear Radio Telescope, a narrowband radio signal erupted at 1420 MHz, exactly the hydrogen emission line frequency long considered the cosmic communication channel. The signal was 30 times. The WOW signal remains one of SETI's greatest unsolved mysteries and unexplained data point. Science that slices reality into pieces too small. Maybe all the data we need to confirm the extraordinary is already out there, publicly posted on archive servers, but so fragmented it's invisible. It's just silently waiting for someone or something capable of seeing the forest instead of individual trees, and stitching all the pieces together. From probes to natural-looking artifacts, speculation December thrives in the dark. When official observation stops, imagination takes the telescope. According to Loeb's calculation, 3I Atlas's orbit traced backward through interstellar space originates within just 9 degrees of the WOW signal's original direction. Though not a perfect match given decades of accumulated uncertainty in both measurements, it's close enough to demand attention. Loeb calculates the probability of this alignment being random at just 0.6%, rare enough to warrant serious consideration. The most viral narrative claims 3I, then the timing WOW signal in 1977, 3I Atlas at perihelion in 2025. In real physics, we know extreme solar proximity can do wild things to materials. Under intense perihelion radiation, composites or metals can develop charge differentials, effectively turning them into self-discharging circuits. If 3I Atlas carried such architecture accidentally or deliberately, a long-dormant antenna array could spark back to life. A sensor buried deep under rock could reboot. And then the evidence gets a 48-year gap. This is almost the perfect time frame for an advanced probe designed to travel interstellar space after sending a precursor signal. And so Loeb's controversial hypothesis connects all these anomalies into a single narrative. The WOW signal was a deliberate announcement, after transmitting that civilization dispatched a probe to follow. That probe, after decades of travel, is 3I Atlas. In this scenario, the non-gravitational force we're observing isn't natural chaos. It's performing a gravity assist using our sun as a slingshot to chart its next course. We're witnessing first contact, but we haven't realized it because we're still interpreting it as a natural comet. This story resonates deeply with science fiction longing, turning the WOW signal from a forgotten mystery into the opening chapter of an ongoing interaction while giving 3I Atlas purpose intent. Polarization anomalies. Subtle deviations that weren't random. They showed periodicity, a pattern. Hard to prove, harder to dismiss. If true, this would be the most profound discovery in human history itself. A form of communication so and then the evidence gets fundamental it's beyond our translation capabilities. Instead of symbols or signals, the medium is the universe's constants. Think of it as algorithmic art etched in motion, a deliberate synchronization between thermal radiation and reflected light, designed to convey information through rhythm timing. a binary pulse train painted on. Yet the scientific community, especially the SETI community, has pushed back immediately and forcefully. Researchers invoke Occam's razor. The simpler explanation is usually correct, and an artificial probe requiring an advanced interstellar civilization is far more complex than a natural comet. Moreover, they point out the biggest flaw. 3I, Atlas, is completely silent. If an advanced civilization, instead it behaves identically to a natural comet mute and governed by sublimation forces. Scientists also note that when angular uncertainties are properly calculated, the statistical significance of the WOW alignment drops significantly from lobes 0.6%. Finally, the WOW signal itself has plausible if controversial natural explanations. In essence, this story remains a tantalizing, but to truly understand what 3I Atlas represents, we need to set aside the question of who built it and focus on something far deeper. When was it built? This isn't a young comet. Based on chemical analysis, 3I Atlas is estimated at roughly 10 billion years old. That number is almost This raises a question bigger than SETI. Where did it come from? What kind of star system produced a 10 billion-year-old comet? What can we measure? What can we check? Could deep space radio arrays listening to the cosmos catch a faint narrowband transmission near its reemergence? Could detailed radar mapping reveal in a probe? Microvelocity. 10 billion years ago, the universe was very different from today. The first generation of stars had lived and died, but the abundance of elements heavier than hydrogen and helium, what astronomers call metals, was still extremely low. The composition of protoplanetary disks determines what kinds of objects form. If the disk is CO2-rich, which requires very cold temperatures to freeze, stars and planetary systems forming 10 billion years ago would be significantly metal-poor compared to younger stars. The anomalous CO2 dominance and nickel without iron anomaly in 3I Atlas could be direct signatures of that ancient formation environment. CO2 readily condenses in the ultra-cold outer regions of primordial disks, and unusual metal ratios could stem from the nucleosynthesis conditions of the universe's first star. 3I Atlas in essence is a cosmic fossil, a unique object allowing us to study the chemistry of a vanished cosmic era. Surviving 10 billion years of interstellar travel crossing star-forming regions, dense molecular clouds grazing giant stars, and spending most of its time in the frigid void between stars, where temperatures hover just degrees above absolute zero, makes it the most significant interstellar object we've ever had the chance to study. A new order of physics, and because of that significance and uncertainty, December's observations aren't just about taking pretty pictures. They're a cosmic laboratory designed to answer 5 specific questions each. A test of Loeb's hypothesis, or preserves the first whisper of something that has been waiting for us to listen for a very long time. But before we let these extraordinary speculations fully eclipse the sky, we must consider another possibility. One that requires no alien intelligence, no message, no hidden intent. Structural integrity. Hubble's test. The Hubble Space Telescope HST will take ultra-high resolution images to look for multiple bright points or asymmetries in the coma clear signs of fragmentation. If Hubble reveals a cluster of fragments, it shows 3I Atlas was far more fragile than expected, supporting the hypothesis that natural sublimation forces destroyed it. Conversely, a single nucleus would bolster integrity at millions of degrees Celsius, while the visible surface just below it, the photosphere, glows at a mere few thousand. It's as if the air around a brightness and activity level. Optical tests. Large observatories will track the comet's activity decay as it moves away from the sun. If brightness remains significantly higher than known sublimation models predict, it could suggest anomalous post-perihelion outbursts or non-natural activity requiring deeper study. The mainstream scientific picture believes chemical composition JWST and VLT tests. The James Webb Space Telescope JWST will use infrared spectroscopy to remeasure the carbon dioxide-water ratio, comparing it to the preconjunction 8-1, to see if perihelion heat release different chemicals from deeper ice layers. Meanwhile, the Very Large Telescope VLT will orbital analysis JPL test. This is perhaps the most critical test. NASA's Jet Propulsion Laboratory JPL will synthesize all December position measurements to determine exactly how much 3I Atlas's path deviated from pure gravity predictions. This test will provide quantitative evidence of thrust from non-gravitational forces. If the orbital deviation fits random directed sublimation jet's natural behavior, radio observation's clearest artificial tests, powerful radio arrays like the Very Large Array VLA in New Mexico and the Atacama Large Millimeter Array, ALMA, in Chile, are scheduled to search for any radio emissions that could indicate artificial transmission or structure. Natural comets are essentially silent. In summary, the overwhelming consensus in the scientific community is that December's observations will confirm 3I Atlas as a natural comet, albeit with anomalous chemical and behavioral traits. The expected scenario is structural integrity will be maintained, brightness will decay at natural rates, and the orbit will show deviations explainable by chaotic sublimation models. But certainty and expectation are not the same. And this is what the 3I Atlas event gives us. It's a real mystery, not manufactured sensationalism, but genuine scientific uncertainty about an object that has consistently surprised us. The sunward jets nickel without iron, CO2 dominance, the wow signal alignment. Each can be explained individually, but together they paint a picture of an object that doesn't quite fit our existing categories. Science advances through mystery. It forces researchers to push telescopes to their limits and think deeper about the diversity of stars. Perhaps the greatest value of 3I Atlas lies not in its true nature, but in what it forces us to contemplate. It asks how many other ancient wanderers are making their own journeys across the galaxy. How many times has Earth been visited by objects from other star systems without us noticing? We're entering an era where such visitors will become routine. Next-generation surveys may detect interstellar objects at rates of dozens per year. It's close enough to demand attention. The scientific commission. Loeb calculates the probability of this alignment being random at just 0. But this mystery, this 10 billion-year-old CO2 lump coincidentally aligning with the WOW signal passing Mars at the perfect moment and hiding behind the Sun at perihelion, will always be the one that made us wonder. How certain are we about what we're seeing? We know extreme solar proximity can do wild things to materials. Under intense perihelion radiation, composites or metals can develop charge differentials, effectively turning star systems into self-discharging circuits. If 3I Atlas carried such that question, that moment of uncertainty, the willingness to consider possibilities that challenge familiar assumptions, that's what makes science human. December will come. The comet will emerge. Data will be analyzed, but it won't erase the wonder. It won't erase the memory, and perhaps that's the silent message woven through this era of astronomy. Clarity is not truth. The universe remains a mystery wrapped in light. The next revolution won't come from glass and mirrors. It will come from algorithms. Artificial intelligence is beginning to rewrite how we perceive the cosmos. The eye of the future isn't a telescope. It's a mind made of code, and what it sees may change everything. Artificial intelligence has quietly become the invisible co-author of modern astronomy. Every deep space image we celebrate, those stunning portraits of nebulae, exoplanet disks, has been shaped by an unseen algorithm. In mid-2025, a new leap arrived: Amigo, a neural reconstruction system. Its purpose sounds simple: recover faint astronomical signals from JWST. In reality, it's a silent revolution. Amigo can rescue structures buried under glare, reconstruct stars lost in overexposed regions, even interpolate missing dust lane fragments. To the human eye, its recreated images are breathtaking. Sharper, deeper, almost too perfect. And that's the problem, they're too perfect. For the first time, machines aren't just processing the cosmos, they're interpreting it. Amigo's neural engine doesn't just remove noise, it infers what missing information should look like based on billions of learned patterns. That means reality itself as we perceive it is filtered through statistical imagination. The universe's faintest echoes are being resurrected, but this new power comes with a heavy philosophical price. If machines now control our perception of the cosmos, how do we know what's real? That question becomes urgent with 3I Atlas's reemergence. The first scattered images allegedly capturing its faint light were processed through similar AI systems. Within hours, speculative frames began circulating. A subtle brightness flickered through AI filtering becomes a pulse. An asymmetric blur through AI becomes orbital deviation. The silent danger lies here. These neural tools aren't malicious. They're obedient. They fill gaps based on training data based on what they expect to see. When input strays too far from known models, the system improvises. And in that improvisation, bias becomes synthetic physics. The universe is bent not because it behaves differently, but because the algorithm expects it to behave like before. Consider a faint brightness deviation. Raw data is noisy. The neural filter steps in, enhances contrast. What emerges looks rhythmic. To human eyes it seems real, but is it an algorithmic artifact or evidence? In the AI era, uncertainty wears the mask of precision. The algorithm doesn't acknowledge its guesses. It smooths the rough edges of ambiguity into seamless certainty. And that's the most dangerous illusion: misplaced confidence. The consequences stretch far beyond 3i Atlas. AI is now flagging techno-signature candidates before astronomers even know where to look. Machines are the first witnesses. Humans follow. We no longer see the pristine cosmos, but an AI-curated reality. So when the next batch of 3i Atlas data arrives, we must ask, are we seeing the universe as it is, or as our neural filters imagine it? And there's a deeper irony. The success of these systems relies on an assumption of normality. But what happens when something truly anomalous appears? When a signal genuinely breaks the mold, chances are the machine will discard it as unexplainable noise. The extraordinary could be erased before it reaches human eyes. The very intelligence we built to seek the unknown may be filtering it out. How many great discoveries lie not in distant stars, but in the discarded decimal places of an algorithm's filter? The frontier is no longer in the stars, it's in the training data sets. In October 2025, Oxford University and Google Cloud announced something quietly reshaping boundaries. They created a neural system capable of classifying transient events, cosmic phenomena that flash and vanish with unprecedented speed. For decades, astronomers scanned maps, compared frames, waited hours for consensus. That delay meant missing the critical moment. The Google Oxford system changed that. Now, an algorithm can watch the sky in real time and decide supernova comet solar flare, or the most tantalizing label, unidentified phenomenon. The promise is spectacular. The danger is real. If such a system had been active during 3i Atlas's perihelion, it might have caught what no human ever did. A sudden light spike, an intensity pattern mismatched to solar noise. AI could have triggered an alert. We might have recorded the moment myth became evidence. Or it could have gone the other way. It might have misclassified a solar flare, tagged the event sensor error, and discarded the data before a human ever saw it. That's the paradox of automation speed without skepticism. When a machine decides something isn't worth investigating, its confidence spreads. Machine certainty, even when wrong, travels faster than human doubt. Now imagine that same system linked to social media. A single label, unidentified, high confidence leaks. In minutes, the story spreads. A glitch becomes a mystery. A hiccup becomes a signal. The scientific process built on patience is shattered. Space becomes a collective psychological stage. When 3i Atlas vanished, people didn't just ask where it went. They asked what they should believe. Yet the very system fueling speculation could also save us. By processing millions of data points, AI can detect the subtlest dangerous signatures humans miss. It doesn't blink, doesn't sleep. The core issue is philosophical. Who gets to define reality when the observer is no longer human? We built these systems to extend our senses, but in doing so we handed them the power to choose what counts as evidence. Telescopes were once extensions of the eye. Now they're extensions of the mind. We no longer just observe the cosmos. We co-create it with our machines. When AI flags something as anomalous, it's not just describing the universe. It's shaping humanity's next questions. AI doesn't wonder. It doesn't feel awe. It doesn't hesitate. That hesitation, the fragile gap between knowing and not knowing, is where discovery is born. The future of astronomy will be a conversation between human and machine. And that inevitably leads us to the final question. We began this journey searching for a comet, a craft, or something in between. We wanted data clarity and ending. Instead, we're left with a mirror. 3i Atlas has become an idea more than an object. It's a reflection of everything we project into the void. When it disappeared behind the sun, it took our hope for certainty and returned absolute silence. And in that silence, it exposed something raw. How fragile our relationship with knowledge truly is. Seeing is no longer simple. Every observation passes through layers of mediation, digital processing, algorithmic filtering, institutional gatekeeping. Truth must compete with virality. When 3i Atlas passed perihelion, no human eye saw it directly. The decisive moment of the entire mystery unfolded in absolute darkness. What remains are fragments, a heat flare that shouldn't have been. An hour of missing data. Beyond that, only speculation. But perhaps this ambiguity isn't failure. Perhaps it's a new horizon. The history of science isn't a history of answers, but of deeper questions. We once thought discovery was revelation, but perhaps it's becoming a negotiation between evidence and humility, between belief and doubt. Perhaps that's the true message of 3i Atlas. Not a transmission from outside, but a reflection from within. In control rooms across Earth, instruments stand ready. NASA dashboards count down. All eyes point to one window, mid-November 2025. The world will look forward again, and what will we find? Maybe nothing, a faint object, the cosmic equivalent of a whisper lost in solar noise. Or maybe something else, a spectral shift, an orbit that doesn't quite fit. If that happens, the debate will reignite. But even as the mystery deepens, one irreversible thing has occurred. Humanity has glimpsed the edge of understanding and realized we cannot see beyond it. With all our models and AI, there remains a veil we cannot pierce. The question is no longer is 3i Atlas rock or signal. The question is that we looked and for the first time felt like the universe was looking back. That silence isn't absence, it's acknowledgement. Now, as the world waits, the real story turns inward. The challenge of our era isn't how to collect truth, but how to recognize it when we see it. In the 21st century, every mystery becomes a reflection of the observer, and perhaps that's inevitable, because wonder, true wonder, cannot survive absolute certainty. The moment we define everything, we stop searching. 3i Atlas may never give an answer, but it has fulfilled its purpose by reviving the one thing we risked losing in the algorithmic age. The capacity to wonder. The old question, what is it, has become. What does it mean that we don't know? So now we wait. Not as scientists, but as witnesses. When the next light emerges from behind the sun, telescopes will swivel, and once again humanity will hold its breath. But the true discovery won't come from data. It will come from the realization that we still have the capacity to wonder. Because the next light we see may not just reveal the fate of 3i Atlas. It may reveal what kind of species we've become, one that demands proof before daring to believe. Or one that learns to live gracefully with the unknown. And somewhere beyond the sun, whatever decision was made by rock, by radiation, or by reason is already on its way. The echo of that silent crossing still reverberates. When it arrives, it may change nothing, or it may change everything. But either way, the universe will speak not through answers, but through absence. And for the first time in a very long while, we will be reminded that not knowing is the beginning of all wisdom.